Greetings of the day. In this video, we will discuss the tree data structure, which is a hierarchical data structure. In the previous videos, we have discussed the linear data structures like stack, queues, and linked list. Here, we will study a example of a non-linear data structure, which is trees, which is a hierarchical data structure. So first, before we start understanding the operations that could be performed on tree data structure, we will understand some of the terminologies and the different classification of this type of data. Trees are mainly used to represent data containing hierarchical relationships. For example, records, family trees, and table of contents. It usually has a parent-child relationships. So one is a parent and it has two childs, that is 2 and 3. 2 is again a parent which has two childs. So this is a simple example of a tree representation. Tree is an abstract model of hierarchical structure that consists of nodes with parent-child relationships. As you can see, tree is a sequence of nodes, and the starting node of the tree is called as the root node. So A is the root node in this diagram. A has three children, B, C, D. A is the parent of B, C, and D. Every other node that the root has a parent node, other than the root, has a parent node. Root is the only node that doesn't have a parent node. Nodes may have any number of children. This is a simple representation of parent-child relationship. Here is another diagram to understand the different terms of the tree data structure. A is the root node which has no parent. So the tree is categorized as different levels. The level 0, which contains only the root. In level 1, it has two children, that is B and C. So B is the parent of D and E, that is D and E are the child of B. D is called the left child and E is called the right child. Similarly, C has two children, F and G. So this forms a subtree with as, uh, F as its root. So within a tree, we can even have subtrees. The last node that has no childs are known as the leaf node. The nodes with the same parent are known as the siblings. So this is the summary of the different terminologies in the tree. So let's understand some more terminologies. So far we have understood what is the root, which is the topmost node of the tree. A parent, any node except the root has one edge upward to a node that is known as a parent. Child, the node below the given node connected by its edge downward is called the child node. Child of the same node is called a sibling. Leaf is the node that doesn't have any child. So here we need to understand some more terms, that is height of the tree. Subtree is the represents the descendants of the node. So as we can see here, BDE forms such subtree. The levels of the node represent the generation of the node, as in our real life, where we have different generations. So the tree data structure also has different generations. If the root node is at level 0, the next child node is at level 1, and so on. The key represents the value of the node based on which the search operation is to be carried out for the node. The next term we need to understand is what is the degree of a node. The degree of the node is the number of children of that node. For example, A has three children and D also has three children. So the degree of the node A and D is 3. Similarly, B and G. So D has two children and The node G also has two children, so the degree is 3. C and E has one children, and the nodes K, F, L, M, H, I, J has no children, so the degree of these nodes becomes 0. The degree of the tree is equal to the maximum degree of the nodes of a given tree. So in this example, the maximum value of this set is 3. So 3 is the degree of this particular tree. Let's understand what's the meaning of height of a node. The height of the node is the maximum path length from the node to the leaf node. So now if I want to understand what is the height of this node. See, the leaf node in this path is the orange. The The nodes that are circulated in orange color represents the leaf node. So the path, the height of the node is the maximum path length from the loop. So this has 3 steps. So the height of the root node is 3. Now the nodes that are at level 1. So if you look at this, the height of this node is 2 because it has to pass 2 steps to reach the leaf node. The height of the tree is the height of the root. Height of the tree is the height of the root. So the depth of the tree is the maximum level of any leaf. So in this case, the maximum depth is 3. So that means the depth of the tree is equal to 3 in this case. So this is another example to understand the height, the depth, and the degree. So these three terms play a very important role in understanding the tree data structure. Here is another example to understand more detail about height and depth. So let's understand the classification of trees based on the number of children that it has. So trees can be classified as binary tree, ternary tree, and n-array tree based on the number of children. Binary tree contains nodes that has at most 2 children. Ternary tree can have at most 3 children, and n-array can have any number of children nodes. So here is an example of binary tree. That means it can have at most 2 children. Ternary tree is a data structure that has at most 3 children node distinguished as left, mid, and right. In case of binary, we call it as left child and right child. N-array or generic trees are a collection of nodes where each node is a data structure that consists of records and lists references to the children. Or duplicate references are not allowed in this case. So in the next video, we will discuss more about binary tree and different traversal techniques and binary search tree algorithm. Thank you.